Hello guys, I am Deepak and I am from KL. Today I am here to tell you about COA. COA stands for Computer Organization and Architecture. This is the major subject in CSC and both EC because in the COA we are learning about the computer and its components regarding the programs and everything. So here computer organization and architecture. The name itself tell you about it is related to computer and computer organization. So these two words, computer organization. Computer organization is related to the program and the programmer acceptable and the program will only accessible parts. So here it is internally defined. So computer organization is internal parts and computer architecture. That means the outer parts, the peripheral devices and input and output devices where we can see and we can touch with our hands are called computer architecture. And these are CPU, memory, and input and output devices. These are peripheral devices. So hereby we let us introduce our COA topic introduction. That means it is related to the CPU, RAM, ROM, memories, etc. And thereafter there are state machines. That means finite state machines. These are also known as FSL. So this is about the transferring of data from one machine to that is in one state to another state. These process tell you about the state machines. So hereby finite state machines are divided into two types. They are Mealy machine and Murray machine. So these are two finite state machines. So in Mealy finite state machine, hereby it is depends on present state and present input. But in Murray, it is only depends on present state itself. So hereby, if you any input change is there, then the output also changes with the input according to the input. And in the Murray state machine, the input change means the output doesn't change. So it is only depends on Murray only states. So hereby we have present state and next state. So hereby we can differ the Mealy and Murray with the present state and present input. So we have the final state diagrams of the Mealy and Murray final state machine. So hereby you can see on the screen itself and you can analyze it by the following next combinational logic circuit according to the state register and out combination logic. So here you can see that the input is taken from the output and another input is given from the input itself. So hereby we can know about the Mealy machine as it is input and output is depends on present input and present state. So and Murray is you can see the final state diagram of Murray machine in the screen and here it is only depends on present state and no input is dragged from the output. So these are the differences between Mealy and Murray state machines. As I told you earlier about computer organization architecture. So hereby computer organization and architecture. So it is divided into computer organization and computer architecture. In computer architecture, there are two types. Basically, it is defined by RAM and ROM storage. So if you have separate RAM and separate storage, so it is one architecture, and if you combinedly called RAM and ROM as a single memory, it is separate architecture. So hereby computer architectures are divided into two types. That is value architecture, and another one is Harvard architecture. So value architecture is old one, and Harvard architecture is somewhat new version. So hereby in value architecture, the RAM and ROM is allocated in a single memory, but in Harvard architecture, both RAM and ROM are separated and they have separate spaces. So in value architecture, they have small space with input and output, and in Harvard architecture, it have separate space for RAM and ROM. So as it is registers and input and output devices. So it occupies more space, but it occupies less space. So Harvard architecture is faster processing unit because in Harvard architecture there is separate RAM and ROM. So when there are separate RAM and ROM, so execution and storage part is separated by itself. But in Van Neumann architecture, both have only one memory. In that memory only, both the RAM and ROM are inculcated. So in order to attain the speed and in order to store the data, it has to be a bit slow compared to the Harvard architecture. And Harvard architecture is costly because it has separate spaces for RAM and ROM. But Van Neumann architecture is compared to Harvard, it is somewhat low because Van Neumann architecture has lesser space and it has somewhat slow processing. So hereby it is also differed by the speed of execution and the controlling complexity. The Harvard is somewhat high level because it has separate, and Van Neumann is simple because it has same memory space. So hereby I conclude the class with these topics: the finite state machines and architectures and introduction of COA. And hereby you can know me. My name is Deepak, and you can stay tuned to the KL channel. I will be available in KL channel. You can ping me in any doubts in the comment section. Switch on the subscribe and switch on the bell icon. So stay tuned to KL. Thank you.